Welcome to the shop, everyone. On today's video, we're going to be verifying the compression ratio on this Big Block 454 build. Now, here are some of the tools I'm going to be using to get the compression ratio and also to find a cc volume of the chambers there. Now, I went with the syringes just because I thought it might be the cheapest way to go about doing it. You can buy those on Amazon or eBay. Also, they have milliliter graduates, but milliliter and cc's are the same thing. And also green alcohol. I like the surface tension of it. And then also a graduated cylinder. And I seem to like the graduated cylinder a little bit better as far as the measuring. Alright, so the first thing we need to do is seal up the chamber so it doesn't leak. Now, some people even will like open the valves up and put like a little bit of grease around the valve to kind of be a seal there, but these heads here seem to seal up really good, so there's no leakage there. So I'm just going to be sealing up the chamber on the outside and with a piece of plexiglass. Now, the plexiglass, I just ran down to Home Depot and they sell little pieces there, and I drilled a hole in it, and then the grease seals it to the cylinder head. So we're going to use the syringes first. I found the easiest way to fill that up was just to put a piece of hose on there, and I could actually draw some out, and then where I had the air bubbles and the air trapped in the top, I could push it all the way back out and then draw back down to the 100 milliliter mark. Now, since the chambers are advertised at 112 cc's, I knew the whole 100 milliliter syringe would, it would take that whole one, so I just push it straight in there. Now, the second syringe I bought is 60 milliliter, and I thought the graduates or something, it might be a little bit more accurate, is why I bought that, but I ended up not really liking the 61 milliliter one, so I filled it up the same way. Now, one thing I didn't like about the syringes is at the nose, at a tilt, sometimes some of the alcohol would leak out. And also, for whatever reason, when I was pushing on the 60 milliliter syringe, it wasn't smooth, so I didn't have the control that I hoped I would have. But it just could have been, maybe it didn't like the alcohol or whatever, I'm not sure. Alright, sometimes you'll have some air bubbles. You can actually pick the head up and down, move it around, tap on it a little bit, try to get the bubble come out, and then you can finish filling it up. Alright, so by the syringes, we have 100 milliliter in there, and that one there is 10, looks like a heavy 113 cc's by the syringes. Now we're going to use a graduated cylinder, and it's more of a lab type piece of equipment. I feel like it's a little bit more accurate. The hardest part with it is pouring it into the chamber itself, but it actually worked out well. I was able to pour it in there without any trouble at all. Alright, so we got our 100 milliliters in there. Let's fill it back up. Alright, let's see what we got. Now the graduates there is 1 cc, so we have exactly 112 cc's by the measurement of that system. So let's get the other cylinder head on there and verify that it measures at the 112 cc's as well. Now the reason I'm doing this now is, you know, when I was buying the parts for the engine, I had a target compression of anywhere from 10 to 1 to 10.5 to 1. So all I'm doing now is I'm verifying I'm with that within reason of those, you know, compression ratios I was hoping for. Because at this point here, you know, I could have the head milled. Say the compression ratio is a little bit low, I could have the head milled. Say the compression ratio is a little bit high, I could have a thicker head gasket. So I still have a few options to get in that target area that I was shooting for on this engine. And I think we're going to find out that these, you know, I bought these AFR heads and they had CNC chambers and everything. And I think we're going to find out that they, the accuracy is very good on this stuff. So we'll finish this one up. And I also thought too, if I had bought some eyedroppers, that might have even been even easier on the second part, because whatever's left in the eyedropper I could have dripped back. But there we have exact 112 again cc's. So both heads measured to be the same. Now the part I did like about the syringes was getting that alcohol back out of there. Years ago I used to just like open the valve up and let it drain out the port, or use a rag to sop it up. But with these syringes I could suck a lot of that alcohol out and save it. And even green alcohol, at least where I live, was kind of hard to find. So I actually had to make it with some green food coloring I had. And with the leftover alcohol, you can actually use that to help clean up the grease. Alright, so we CC'd those. They're advertised at 112. We found out them to be 112. So the next thing is the cylinder head gasket and how thick it is and the area it has. So when you look at that, you can see that the thickness of the head gasket, we need to figure out how many cc's would fill that area, the thickness of the head gasket. And luckily, Velcro offers that information for us. So those head gaskets there have 9.17 cc volume. So the next thing I want to figure out is the deck height. Now on this engine I went for about a 5 thousandths deck height. That means the deck is 5 thousandths taller than the piston. So with the dial indicator, all I'm doing is getting the piston square in the bore on both sides, and then I'll be able to verify what my deck height is. Alright, so it looks like I have a 6 thousandths deck height, and so I have to do some math to figure out how many cc's that is. Alright, also on this engine, I machined valve reliefs on the intake side because of the bore size. I put those valve reliefs in there maybe to help flow a little bit, but also I wonder, well, how many cc's are those? So I'm going to take some clay, an old piston, and see if I can't figure out how many cc's that relief is. So I just stick an old piston in the bore, I take a little bit of clay, and I push it into that relief. Once I have it pushed in there real good, I'll take a razor blade and cut it off at the deck. I pull it out. Alright, so there's a valve relief. And so now I'll take that graduated cylinder and I'm going to fill it with alcohol, say to 70 milliliters exactly. And then I'll peel off that little piece of clay and I'll drop it in there, and however much higher the alcohol raises will be how many cc's that relief is. Alright, let's drop it in there and see what we get. Alright, so it looks like about 1 cc. Alright, so we got that too. Now the piston pop top, how many cc's that is, and Wiseco offers that information. They're saying it's a plus 21 cc pop top piston. So I can take all that information, I can do some calculations with it, and by the calculations I came up with, I have a 10.146 to 1 compression. You can round that up to 10.15 to 1 compression. But to check myself, I went to Summit Racing. They have a compression calculator. I put all that information in there, and it came up with 10.15 to 1 compression ratio. I also went to Butler Performance Compression Ratio Calculator, put the information in there, and also got the 10.15 to 1 compression ratio. So that verifies it for me. I'm in the the tolerances I was hoping to hit with the compression ratio. The end of the video, I have how I went through the calculation for any of those who are interested in maybe learning that stuff. But I hope you guys enjoyed the video. Hope you guys give me a like, subscribe, ring the bell, do all those things to help us keep going. And we hope to see y'all on the next video. Thanks so much. Alright, so calculating the compression ratio for this engine, here's the steps I went through to find it. So we've already gone through and we've figured out like our deck clearance, our valve reliefs, our chamber volume, our head gasket volume, our piston volume, alright? But I also need to know the bore of the engine. So this 454 here is a 30 over, so the bore diameter is 4.280 now. And then we also know, to get the cubic inches, need to know the stroke. So it has a 4-inch stroke. Alright, to figure this out, I need the radius of the diameter. So all I do is divide the diameter by 2 to get the radius of this 2.14. Alright, so let's see. Diameter is 4.280 divided by 2 gives us a radius of 2.14 with our 4-inch stroke. Alright, and so I came up with a cylinder volume of 943.170 cc's, and this is the calculation I did to get those numbers. Alright, so I took pi 3.142 times radius 2.14, then to square it I times radius again 2.14, then to cube it I did times 4 the stroke of the engine, and that gave me 57.556 cubic inches. Alright, to convert it to cc's, 1 cubic inch equals 16.387 cc's. So I take the 57.556 times 16.387. That gave me a total of 943.170 cc's. So there's our cylinder volume. Now our deck volume, that's where the deck was 6 thousandths taller than what the piston is. And so for me to come up with this number, I basically did the same thing. So deck clearance volume, so it's the same, pi 3.142 times the radius 2.14 times the radius to square it 2.14 times, now this time instead of 4 inches we only have 6 thousandths to cube it. So that's the cubic inches, that number right there. So I take that number right there times the 16.387 to come up with 1.415 cc's. So that's how I came up with the deck volume. So the next thing was the valve relief in the deck. and we had took clay and found that to be about 1 cc. The head chamber is advertised at 112, and we found it to be 112. The head gasket, they offered that information of 9.7 cc's. And then the piston dome is advertised at plus 21 cc's. So now we have all the information to plug in there and find out what our compression is. So what I did is I added the chamber of 112 plus the deck volume plus the head gasket volume plus the relief I had ground in the deck volume to come up with a total of 124.115 cc's. Now, after doing that, I took that and then I subtracted 21 cc's for the pop top piston. That gave me a total volume of 103.115. Alright, now I take that number and I add it to the total cc's of the cylinder. So I add those two together and it gives me a total volume of 1046.285 cc's. So now I take that number, divide it by the chamber number, and it gives me a compression ratio of 10.146 to 1. And you could round that up to be 10.15 to 1 compression. Alright, hope this helped, guys. Thank you very much.